All right. Hi, everyone, and welcome to Data Quality Meetup number 4. We are very excited to see you all today and also to have really amazing speakers from a few great companies with us. We are going to start in just a few minutes just to give a few more folks opportunity to join. And in the meantime, I'll just speak a little bit about the logistics today. So we're going to have 5 lightning talks. They're called lightning because they are short and concise, about 7 minutes, on different topics ranging from data culture to data quality investments to different frameworks and tools for making sure that your data quality stays high. And then we're going to have a panel discussion with data leaders from both the industry as well as teams building tools for data professionals. In the app, in the live stream app where we all now connected, we have a chat. So feel free to ask questions or give feedback and give props to speakers. And also during the event, we'll be doing some polls just to ask your opinion on certain topics. And while we're waiting for everyone to connect, I'd like to start with a short icebreaker. So why don't you all say, just type in where are you dialing from today and what is your favorite soft beverage? By the way, if you find the chat notifications distracting, you can mute them. There's a button. It looks like a bell in the app. So awesome. Looks like we have a really global meetup today, which is pretty much as usual. So it's really great to see you all dialing in from everywhere in the morning and in your afternoons. And I think we should start. So I'd like to kick off with the first lightning talk today. And my name is Gleb. I am CEO and co-founder of Datafold. We are building a data observability platform. But in my previous life, I was a data engineer at Autodesk, Lyft, and Phantom Auto. So got to work on a lot of problems that we're going to be discussing today hands-on. And my lightning talk today is about what I think is the best data quality investment you can make in 2021. Sounds ambitious. So to start, let's think about what are the typical ways data can break. And I'd like to think about that in 2 broad categories. One, data we don't control suddenly changes. So let's say app engineers break events or vendors fail on us or infrastructure breaks. And the second type of failures is when we make changes to the code, let's say in our SQL files or PySpark or our BI tools, and knowingly or unknowingly introduce regressions or break things for our stakeholders. And so both groups are really important. And since data quality is what I'm doing for living, I've had probably over 200 conversations with different data teams over the course of last year. And there are 2 outcomes I'd like to share today. One, there is a lot of excitement about this sort of black box anomaly detection. Tell me when my data is broken. I don't know what I don't know kind of tooling. But at the same time, I haven't seen a lot of teams that really were very successful in implementing those solutions. And at the same time, teams that really, I think, doing it well and nailing the data reliability in their companies are focusing on slightly different thing. They focus on not breaking data. Because if we think that's pretty logical, right? It's much easier to not break things than to fix them. And to illustrate my point, I'd like to give an example from the industry. So nuclear energy is safe. And if you don't believe me, you can consult Wikipedia, but let's assume it is safe. And the reason why it is safe is because there's so much investment that goes into making sure that all the processes and tools and constructions are reliable and safe. And the reason for that is cleaning up a nuclear incident is a million times more costly than preventing it from happening, considering all the investment. And I claim that the same is true for data pipelines, although luckily most of us don't face such terrible consequences of incidents. And the reason why data incidents are much more costly to fix once they're in production than to prevent is because, one, when something happens in prod, the damage is already done. Execs already looked at broken dashboards, or worse, made decisions based on wrong data. The quality problems cascade. So if you have bad data in one table, then other tables consume it and also propagates to BI tools. It gets cached, becomes a huge mess to clean up. Identifying root cause is really hard once something happens in production. And finally, you also have to fight the business momentum, right? So by the time you discovered something is broken in your data pipelines or dashboards or data products, the organization has moved on. People are working on other projects, so you have to convince them to actually go back and fix old bugs, and everyone hates to do that. And so that's why I think that investing in a reliable change management process in your data products is the best investment you can make. It's better than Bitcoin. And this is almost funny because Bitcoin just crashed. And the way we can implement reliable change management process, I think we can distill in three main principles. So principle number one, you should version control everything in your data products. And luckily today, throughout your entire data value chain, starting from event tracking to warehouse to transformations to BI, we have tools that really support that. Why would you want to version control everything? Well, because if your code that processes the data is version controlled, then you can, one, isolate the issues, you can revert them, and also you always have the audit of all changes that are being made. Two, the second principle is knowing the impact. And what does it mean? It means that whenever someone is making changes, everyone involved, both the people making the change and also the stakeholders, should know exactly what is the impact of the change. How do we implement it? Well, one, we can use assertions. So assertions help us codify our assumptions about the data in the data processing code. For example, that in your table about orders, the order ID should be unique. And tools like dbt, Great Expectations, and lots of other frameworks for building data products really help you do that. The second tool you can use for impact analysis is data diff. Basically, the idea is that we know the change in the source code, and we also want to know how the change in the source code affects the data which gets produced. For example, see how on a given trip, the data changes between production and development. And many of you know me as data diff guy, because that's what we also built at Datafold, but we didn't invent it. Companies like Uber, Lyft, Spotify, to name a few, are building this tooling internally as well, because it gives a lot of visibility into the changes that you're introducing. We only made it accessible to everyone. And the third type of tooling that's really helpful is lineage. So lineage helps you understand the direction of your data flows and how your data travels throughout your entire stack. And why is that important is because when you make a change, you can understand and immediately see all the downstream consumers of your data. So other executive dashboards that are going to be affected, or machine learning models. And you can also stretch that to changes that are made by engineering teams that are producing data, so they know what they're affecting. And so that visibility is really helpful. Again, there are multiple tools that support that. Datafold is one of them, but lineage in general is a really powerful tool you can use for impact analysis. Now, the third principle is not about tools, it's about the process. You should design, implement, and enforce the process for making changes. And I'd like to stress the enforce part, because if you think that if you have all the nice tools to do impact analysis and test the changes, that people will just do it, unfortunately, that won't happen unless the process is requested from everyone to follow. And to give you another illustration from the industry, aviation. So one of the most frequent accidents in aviation is what's called belly landing. It's when the plane lands on its belly. And the most frequent cause for that is pilots forgetting to deploy their landing gear, which is quite surprising, isn't it? And so to fight this, aviation industry came up with the idea of checklists. So whenever pilot, and before the pilot is allowed to land the plane, they have to go through a formal checklist and report the completion of that checklist. Only then they can safely land. And if pilots forget to deploy the landing gear, rest assured that your data engineers, your team members, and you as well will sometimes forget to test your data changes. So to summarize, I think that the best data quality investment you can make in 2021 is the change management process. The way you make it reliable is by 1, applying version control to everything, 2, understanding the impact of every change and making it visible to your team and to your stakeholders, and 3, implement and enforce the process. If you'd like to talk more about that, I'm always available in Slack, in DBT, or Locally Optimistic, and also at gleb@datafold.com. Thank you. All right. So I would like to invite on stage Jason Carey. He is joining us today from Lyft, and is going to show a really cool project that Lyft's been doing to also improve the data quality, both in the change management and in production at the same time. So Jason, welcome.
Thank you, Gleb, and advanced apologies here. It sounds like someone decided to cut some grass right now. So hopefully it's not too noisy, but let's get started here. Okay, so again, my name's Jason Carey. I'm a data platform technical lead at Lyft. I've been at Lyft for about 4 years, and over the last few quarters, Lyft has decided to double down on investing in data quality and promoting trustworthy data. And today I'm going to talk about one of the systems, new systems that we just built to help achieve that, called Verity. So really quickly, some fast facts about Lyft data. I mean,
Sorry, Jason, I don't think we see your screen.
Oh, let's see. Not sure here. Okay, 1 second.
All right. And while Jason is setting up, I'd like to give a shout out to Lyft's team, who not only build lots of internal tooling, but also open sourced some of it. The most famous projects are Flight, which is a machine learning and general purpose data orchestration engine that basically is somewhat competing with Airflow and is quite opinionated, but also quickly getting traction in the ML community. And the second project is called Amundsen, which is an open source data catalog built on Python stack. So I suggest you all check it out. Very, very cool stuff. So take it away, Jason.
How are we now? We're good? Yep, it looks like we're good. Sorry about that. All right.
We're good.
So sorry about that intro. Let's go to some fast facts about Lyft data. So the backbone of our data platform is basically a data lake. We have our content in S3. We use Hive Metastore. We use Spark and Presto for execution engines. And to give an idea of like scale, we are on the order of about 110,000 data sets, about 40 petabytes of data. And if we look from like a query perspective, just like Presto users, we have about 1,100 daily active users. And one thing I want to call out is when we think about users and when we think about extending the platform and building tooling features, we understand like those users break down into different personas for us. For instance, you have SWEs, you have data engineers, data scientists, ML modelers. They all care about data in different ways. They all have different tools in their toolkit and frameworks they like to use. And so when we build services like Verity, We really try to be mindful of that to get the broadest applicability and highest utility to kind of cover and cater to those different use cases. So simply put, like we have lots of users depending on lots of data. And not surprisingly, many of our users lack trust in the data. And there are a lot of contributors to like why they lack trust. And the one I'm going to focus on today is the fact that while we can get our data to the warehouse reliably and measurably, and we get fast query to it, and it's schematized, there's always been this gap around the semantic correctness of the data and making that transparent, visible, discoverable, and enforced on an ongoing basis. As an example, there might be two fields in your data like start date and end date. Is start date always less than end date? Can end date be null? Can a primary key column be null? What's the tolerance for like the completeness of that column? So a lot of these checks are things that we saw as a gap. Like they existed sporadically in code, but they weren't visible, they weren't centralized, and they're really hard to create. So that brings us to Verity. That was exactly what we started to chip away with this system. It's a check-based system to monitor the quality of offline data. And the 10,000-foot view of how Verity works, the right mental model, is three things. One, as a check author, which might be a data producer or a data consumer, you define a check. And in the context of Verity, it's two things. It's a query. What do you want to count? Think like a Presto query. What do you want to count? And then a condition. Is that count what you expect? And that expectation may be fixed or even better, depend on previous check results or be stateful. So it's a bit more robust to fluctuations in the data. The second part is you orchestrate these checks. So we're heavily reliant on Airflow as an orchestration framework as well as Flight at Lyft. And so the idea is basically run these checks when your data changes. Finally, you have to configure who gets notified and how they get notified when there are check failures. So that's the 10,000-foot view. We're going to dig into a screenshot of like what our product UI looks here. There's a lot going on in this, so I'm just going to point out a couple things. This screen is showing check runs for a single check. And in the table in the bottom left-hand corner, we have various rows. Each row you can think of some ETL running, in this case, a daily ETL. And this particular check runs as part of that to monitor the quality of that data. You have the things that you would hope to have. The observed count, that's what you wanted to count or what you did count. The result is showing a range of like your expectation, your condition. And if you look really closely, that condition range in the result column shifts a little bit because in this particular case, it's not a fixed threshold. It's actually based on a look back period and using statistics that adapts with your data. On the right side, we have more details about a particular run, a lot of diagnostic information, really to help aid debugging when there are check failures. And I'm going to talk about on the right-hand side the definition and query tabs as well on the next screen, because I think they're pretty important to the user experience here. On the left side, this is if you were to click definition, this is our DSL we built that a check author would go in and configure. It is YAML-based, but you can see a couple top-level items tied to what we defined as a Verity check. You have a query and a condition. In the query, it's basically a Presto query where dynamic data, such as a date stamp, is injected at runtime. And in this particular case is configuration for a stateful condition that looks at standard deviations, 3 plus or minus 3 in this case. And while that's good and you can see the definition, what users really want to see is what was actually queried against Presto at runtime so that when there's a failure, they can move very quickly in debugging and build confidence that what they configured matches their intuition of what's actually wrong. And that's what the query on the right-hand side is showing. This is the actual query. You know what the date stamp has the runtime value. So that gives you an idea of like what the user interface would be like for Verity as you're authoring checks to help debugging. Architecturally, I'm not going to go through all of this, but just point out a few things. On the left-hand side, top left, we have a customer ETL. And again, we are Airflow and Flight reliant. So we had built custom operator. We have a data quality operator. You can use that, anywhere in your flow multiple times when you're doing your ETL. That operator hits our API basically to initiate checks. And one interesting thing about interaction with this system is that you can run checks in a blocking or non-blocking manner. Why is that important? Well, as Gleb was just talking about, if data is going to violate a data contract, delayed data in many cases is better than bad data. So you can run your check blocking, and if the check fails and you'll wait for that failure, the ETL fails and you can block downstream consumption to mitigate the blast radius. Or you can do non-blocking in a sense where it's fire and forget, run the check, don't block downstream consumption, but still be notified when there are deviations. On the API, we're a gRPC-based API. We have various consumers of that. And then behind that, we have the brains, which is the executor, which does the transpiling between that DSL you saw to basically the execution engine. Right now, we use Presto. It ties into the standard notifiers that we have. And then also we store a lot of state about not just the check definition, but the time series of results in Dynamo, which is really useful, one for robust stateful conditions, as well as just triaging and exploring data in the past. So to wrap it up, like, how has adoption been for this system? Well, we're still kind of the new kid on the block. We came out of our MVP earlier this year, and while our team shifted in size, I would say about 5 engineers over 6 months, including like onboarding of early adopters. That's about the level of effort we've put in, and we're just getting started. We have about 10 teams. They're all internal right now, working with us, running checks in production. There's about 1,000 checks actually running right now. And we've really put an emphasis on, one, identifying what our core data sets are, the most meaningful for the business, so we could tackle those first. We have about 65% coverage. And what that means is we do things like uniqueness guarantees, volume guarantees, key columns being complete, not having nulls there because that can be catastrophic downstream. So that's what we've been focused on. And as a final thing, like what we think is going to come next and what we're going to focus on is, while we're check-based today, we want to move to more passive monitoring where you don't need a human to write checks for 110 data sets. We want to be able to use the historical state of the data and signals about what's important in terms of query access patterns to just have checks automatically online and take the human out of the loop. So that is Verity in a nutshell. Thank you very much. Appreciate the time.
Thank you very much, Jason. It's always really fascinating to see, the internal projects that operate at such scale. Petabytes of data, hundreds of data users, thousands of checks. That's really impressive scale. So our next lightning talk is by Michelle Ark from Shopify. And although Shopify has built also a framework for testing data, it works in a somewhat different way, in a way which I think will make all the software engineers who love the concept of unit tests really smile. So take it away, Michelle.
Sure, thanks. Let me know if you can't see my screen because I can't see you guys anymore. So yeah, I'm Michelle. I'm a senior data engineer at Shopify, and today I'll be talking about how we use DBT to improve data quality at Shopify. So Shopify is an e-commerce platform. We have tons and tons of data because we have to collect data about our own products, but also effectively we're a warehousing solution for more than 1 million other businesses. As much as we push things in terms of just data volume and scale, I think we also really push things in terms of how big our data org is. We have hundreds of data scientists, just over like 60 data platform engineers, 15 plus and always growing kind of service lines, which are these macro teams that data scientists are in. And in our existing kind of data modeling Spark-based monolith repo, we have about 100 PRs merged per week by data scientists. But today, for the scope of the talk, I'm going to be talking about a new modeling tool that my team has introduced, also, I guess, in the same timeline as Jason, about 8 months ago, where we are kind of packaging up DBT with Google BigQuery to provide a SQL-based modeling tool. And really what we added on top of that, which was unit testing, and unit testing the SQL logic that, that users supply for their models. So our motivations for unit testing SQL in the first place are definitely very similar to motivations that you would have for unit testing in a conventional kind of software engineering practice. The main thing is that we really just wanted to give data scientists the ability to assert that their model behaves as expected generally, and also in edge cases that may or may not even be present in the data yet. Another big motivation was just performance, which translates to iteration speed for data scientists, where we can run checks on production data sets, but those will be periodic, not frequent, not really something that you can run on every change or every commit, for example. The other main motivation is the fact that we have tons of data scientists and tons of collaborations on these data models, so that there are frequent updates and, like I said, many collaborators for a single model. And unit testing would really just give data scientists confidence that the changes that they're making to a model that they don't necessarily own won't introduce regressions into the existing behavior. We did definitely look into DBT and its provided data tests, but it doesn't really solve the use case of unit testing. Unit testing is really something that we do in addition to supplying data quality checks through DBT data tests. But just so that we're on the same page, DBT data tests are custom SQL queries that run against production data sets, and they fail if no rows are returned by the test query. And the main downside here is that it's difficult to capture and isolate edge cases in production data. And it's also slow and costly to test for a test that's meant to run on every change. Ultimately, it's running against production data sets. So what we need for any unit testing framework is really the ability to step out or mock out our inputs, run our actual logic, and assert the behavior. So we really need the ability in the SQL context to replace any references to production models with some static mocked out data. Just a quick run through of what that kind of looks like in SQL. Let's say we have the simple model that gets all of the new shops that were created after a certain time. We use just the DBT source macro to dynamically refer to production data sets. So in a unit testing context, we kind of just want to cross that out and instead really reference a CTE, for example. The CTE is hard-coded by static data that's supplied by the user. You can do that for all of your inputs and then effectively run that same one test query that represents, I guess, building the actual model with some static data supply. So we went through a lot of different trials with this, and after a few series of iterations and alphas and betas, we landed on a unit testing framework with Python. Can elaborate later on why that choice, but at Shopify it made a lot of sense with the data science experience. Some of our goals for designing the Python interface were to really nudge users to be able to write unit tests that fail for a single reason. And for that, we needed to make it easy for users to write multiple tests. Some behavior that we've seen a lot in alphas and also in our PySpark system is that we do have unit test capabilities, but users just write one unit test, just sort of super happy path and call it a day. So to achieve that, we wanted to make sure we reduce the verbosity and the redundancy that's necessary to specify and write unit tests. We also wanted to introduce support for more granular assertions beyond just equality, beyond just saying running with these inputs gives me this output. Exactly. And we also recognize that there are these data scientist personas and wanted to give users flexibility in the mechanism that they encode static data. It doesn't really matter as long as they're encoding it. Some people really like a tabular CSV style. Others like more like a data frame or Python list of dictionaries. So just acknowledging that this is just a preference, and we wanted to give users flexibility there. So what we came up with was a unit testing framework where the central kind of object is this mock model object, and that represents some static data with a schema. Here we can see on the right this little code snippet of an example of how you create a mock model. And there are 3 different constructors. You can construct this from a dictionary, a pandas data frame, or a CSV style string. But you specify the name of the model that you're trying to mock out, and then the static data. Here's an example of the data frame, and this is kind of what the inline CSV looks like. I actually really like how this reads out when the whole test is written. It reads very story-like, and it's very easy for review. Then to make the actual mock model with the inputs supplied, it's still a mock model. We use a different constructor and pass in the name of the model we're looking to test, as well as a list of its inputs. Then we can compare it against an expected model. I didn't have space to write it here, but effectively it's also just static data, so you can construct it from a CSV, pandas data frame, or Python list of dictionaries. So we do supply this just basic equals method. But in addition to that, we also integrated with great expectations, and you can use any of those expectations as assertions in unit testing and say things like, my actual model expects column values to be unique. So having more granular assertions, again, trying to nudge users to write very well-scoped unit tests. Okay, so how did this all go? How is it all going for us in terms of the unit testing? Since we launched, we have over 100 models submitted from data scientists and over 300 unit tests. We do require at least one unit test for data scientists, so there's some bias there. The full test suite runtime, I wanted to call this out, but the full test suite runtime takes 22 minutes in a CI environment. We did right out of that implement just like a selective testing where, if you change just one model, we're running the affected tests as in like the upstreams and the downstreams there. So in CI, that takes about 3 minutes because each test is really a round trip to BigQuery in this case. And even though they're short queries, it does add up, and it is a relatively slow test compared to traditional kind of software development tests. And I wanted to give some data scientist testimonials on how this is going from a variety of backgrounds. So we had a new data scientist, Jenny. She's new to Shopify. She was new to data science, and she started working in our system and sort of sent a screenshot saying like, hey, I think something's broken. For some reason, my actual model has 2 rows, but the expected only has 1. Kind of came back a little bit later and realized it was her model and that she has kind of control to change this. I came back and was not that helpful and just said like, yeah, probably it's here. But I think within like 30 minutes, she fixed it, said the test is passing, and she ended up adding, I think, 13 tests for this, which is maybe a little bit overkill. But I think she just found that the first happy path that she tested already had like duplicate data with unit testing. We also had a really interesting conversation with the senior data scientist, Cody, recently, who has fully adopted test-driven development for his data practices as a data scientist. He does it not only for his data modeling workflow, but also for ad hoc requests from stakeholders. He'll go and set up like a dummy DBT model just so that he can use the unit testing and get a really quick iteration speed locally, since each test only takes a few seconds to run with some static data. That's all I had. I hope I didn't go crazy over time. Thanks everyone for listening.
Thank you very much, Michelle. This concept of actually bringing true unit testing to data pipelines is really, really cool. So I am looking forward to Shopify open sourcing it very soon, hopefully.
Yeah, can talk about some limitations that we have and how we're building that out to generalize it as we're going, but yeah.
Awesome. So I'd like to transition to our next lightning talk. And this is a really interesting one because when we speak about data quality, the first thing that comes in mind is, well, data is not there, data is broken, data is corrupted. And one thing that I think also belongs to the conversation about data quality and reliability is security. So today, as we become more reliant on data products, and not only we, as data teams, build data products for internal users, we also start making our data available outside of organization, right? So we publish it to maybe our customers or regulatory agencies, or make it part of the product. And as we do that, it's really, really important that we also focus on making sure that it's also secure. So I'd like to introduce our next speaker, Caitlin Goldgrove, CTO of Hex. So take it away, Caitlin.
Great, thank you, Gleb. That was a great introduction. So hi, everyone. I'm Caitlin. I'm the CTO at Hex, as Gleb said. A little bit about what we do here at Hex. So at Hex, we've built a data workspace that allows you to really easily query data in both SQL and Python, and then turn it into these interactive data apps. And so what I would like to talk a little bit about today is, the security implications of how we do that. So let's see, I should share my screen here. My Google security permissions are making me quit Chrome to do this.
Well, see you soon, Caitlin.
All right, I'll be right back.
Start. Okay. Well, while Caitlin is restarting Chrome, I'll just give a quick shout out to what she's working on. So today, we all know notebooks, right? So Python notebooks, Jupyter notebooks, been around for a while. But as we know, our workflows become really sophisticated, and the functionality of just plain notebook that you run locally no longer really works in a modern organization. So Hex essentially challenges that status quo of Jupyter notebooks and makes it really easy to build both secure, reliable, collaborative version control data products out of your sort of classic Jupyter experience. So check them out. Welcome back, Caitlin.
Thank you.
I was selling Hex while
Awesome.
you were ready.
Love to hear it. Yeah. Turns out I didn't have it allowed to record my screen, which it was asking for. So let's try this again. Entire screen. Still not letting me do it.
Cool. Well, I'll try to fill in the gap by saying that if you enjoy lightning talks and you have something, and I'm speaking to the audience, right? So if you enjoy lightning talks and you have something that you're passionate about, you're doing something really interesting in your organization that you'd like to speak about, we are always welcoming new talks. So please email me at gleb@datafold.com and we'll line you up for one of our next events.
Cool.
Well,
can everybody see this fine?
Yes, perfect.
Okay, great. Sorry about that little hiccup there. Cool. So yeah, so today I'd like to talk a little bit about introducing security into your data apps. So one of these things that we've kind of seen over the last several years is an evolution of the types of data products that people are producing. So back in the day, these used to be super static. These were, PDFs, slide decks, things like that. Kind of moving through sort of traditional BI, much more interactive, but still pretty on the rails in terms of the types of things that you can actually build. But more and more, and Hex is part of this trend, we're seeing people build out sort of fully featured code-based production grade full-on data applications as the product of their data work and their data teams. And these are really, really powerful and they can do a lot of things. But as we all know, with great power comes great responsibility. And the fact that we can do a lot of things means that there are new implications for things that we have to consider. And one of the biggest ones here, as Gleb was mentioning earlier, is security. Your company hired a bunch of data analysts, hired you because they care a lot about their data, and they're trusting you to protect it. And it's easy to think about data security as being, trying to defend against this guy, some shadowy hacker on the dark web who's trying to come get your data. But the reality is, it's actually much more mundane set of problems. We've been talking a lot about, data quality, and that's, data quality, data corruption, data loss. Those are all security issues as well. Sometimes even security issues are as simple as you built an app that allows your users to accidentally run a giant query, your server runs out of memory, and all of a sudden the server is down for everybody else. And then, classically sort of a data security issue of allowing to see people to see data that they don't have, that they shouldn't have access to. And if you have any kind of sensitive data, PII, PHI, this is something that you need to be paying a lot of attention to. And there are a lot of new ways that this stuff can go wrong when you start to move into a world of sort of these like fully fledged data apps. Now, security and application security is a huge topic, way, way too big for a 7-minute lightning talk. So I wanted to spend the rest of the time really digging in on one very common avenue that people often have security issues with their data apps. For the software engineers in the audience, this is probably something pretty familiar. But if you're new to building web applications and you're new to building applications in general, this is just something that's really important to kind of have a good understanding of. And that's SQL injection. So SQL injection is a pretty fun technique here. Let's say that we have a really simple data app where we're allowing people to retrieve facts about their favorite animals. We give them a nice little text box, and they can type in whatever their favorite animal is. And then in our Python, we turn this into a SQL query just with a really simple templated string. We take the animal that the user input and just shove it into our string like this. So this is great. This works perfectly well if the user types in a real animal like platypus or iguana or whatever. But what if the user types in the following: duck, semicolon, drop table, facts? Well, when you put this in the string, all of a sudden you end up with not one, but two SQL statements. Select star from facts where animal equals duck, and then drop table facts. Now, most SQL engines will very happily execute both statements. So after retrieving a bunch of facts about ducks, you will delete your entire facts database. I hope you're backing up your databases. It's another security topic for another time. This example is maybe a little bit contrived. There's other ways of getting around this by making sure that you're locking down your database users and things like that. But the ability to execute for an end user of an app to execute arbitrary SQL against your database is something that we want to avoid entirely, because they can do a lot of really malicious things with that. There's a lot of options, fortunately, for dealing with this. Most of them are pretty simple. One is just don't allow users to type in arbitrary things. In this case, it would be really simple to just change this text field into a dropdown. We could even populate it with all of the animals that are in our database, which is maybe even a better user experience because they'll know exactly what the options are. One fun fact about Hex, we actually have a lot of these different input widgets, check boxes, buttons, drop downs, whatever. And the drop down is actually by far and away the most popular input option here. So you can get a lot of mileage just out of doing this. And in this case, completely safe. You have complete control over what the strings are that are getting input into your query. Sometimes that's not possible. Maybe you can't enumerate all of the possible things that you think a user might input. But fortunately, SQL injection has been around for a long time. So most databases have a built-in construct called a prepared statement. And this allows you to separate out the actual query and the query structure from the values that are actually being inserted, and the database will handle those separately. So they'll treat the values just as harmless strings, and they'll actually run the SQL. So you don't actually end up with SQL that's contained in the value getting executed. Most SQL libraries, have this functionality. Sometimes it's called something a little different. You have to do a little digging to figure out what it is. But this is just a quick example here in pretty common Postgres library, where you pass in the templated string, and then you can also pass in a dictionary of values to go with that. And then lastly, sometimes both of those things don't work. So prepared statements, they actually only work for the value part of the query. You can't actually swap out things like identifiers. So it is a very last resort. You can check user input against a very narrow set of constraints. For example, if you're expecting a column, you can check that it actually is a column in the database. If you're expecting a keyword, you can check that it's one of a very small set of keywords that are valid for this. It's also worth noting that the inverse of this, so this is called allow listing or whitelisting. The inverse of this, block listing, is actually not safe. If you try to just disallow a couple characters that you think are unsafe, it's actually very tricky to do that correctly. But anyway, you have a lot of options when you're going and building data apps, but one general best practice when you're dealing with security is a lot of the stuff can be pretty complicated. So you should never build it yourself if you don't have to. And you should look for tools that support this kind of thing out of the box. I've already talked a little bit about libraries and library support, but really the best possible thing you can do is look at your data tools and look at the tools that you're using to build these data products, whether it's like BI dashboards, apps, whatever, and look for ones that have security baked in as a first-class principle. So Hex, obviously, we care about this a lot. We've built it in. Retool and Looker are also good ones where I know that they've thought really carefully about their security. And this is actually something that I'm just generally really interested in. So if you know of good examples, I'd love to hear about them. But anyway, that's all I really have for today. I hope you learned something a little bit useful and practical about SQL injection. And feel free to hit me up if you have any questions later. So thanks.
Thank you so much, Caitlin. Definitely something that we data people need to think about when we build data products. Cool. So I'd like to introduce our last but not least lightning talk today by Alex Viana from HealthJoy. And the interesting part about what Alex is going to present, and I'd say that is a somewhat controversial proposal, maybe just like my first talk, but it's really thought-provoking in the sense that we data people are used to reacting to people giving us certain directions. Like, let's say, well, why don't we analyze such experiment, right? Or why don't we build a dashboard to, to give certain visibility on a particular kind of business? And a lot of the times we really embark on long journeys to build what our stakeholders are asking us, only to find that maybe that analysis wasn't worth it at the first place. So Alex developed a really interesting framework that he applies with his team of how to make data decisions in the correct order. So Alex, please take it away.
Thanks, Gleb. That was actually better than I've articulated it. So if you could maybe just write that down and send it to me, that would be
sure.
Would be great. Let me see if I can share my screen. Working for everyone?
Yep.
Awesome. Let's take it away. So the title of this talk is Fake It Till You Make It, a backwards approach to data products. So this is my talk in one slide. So my idea is that I believe that one of the fastest and most efficient ways to get people to align with what needs to be done is to put something concrete in front of them to talk about instead of kind of, broad theoretical ideas. And I think one of the fastest ways for us to do that as data people is to just fake the data. So some context here, I am the VP of data at HealthJoy. We are a Chicago-based health tech company. What HealthJoy does is we provide a platform that empowers employees to make the most of their employer-sponsored healthcare benefits. We do this by consolidating everything into one place. So if you need to schedule an appointment, have a medical bill reviewed, find affordable prescriptions, we provide one place to do that and connect you with the value that your employer is already providing, but without the friction of having to do this yourself. So the way our team is structured is we're a strategic function. We report directly to the CEO. We are not a part of the product org or the engineering org. We are our own organization. And we try to build in what are modern best practices that we think are emerging. So this is everything from the concept of our analysts being full stack or analytics engineers, if you prefer that term, or also working in a product-driven as opposed to a service-driven framework. These are ideas you can read more about in the Fishtown or Locally Optimistic, the DBT communities. We find them to be very effective, and we've been able to build a whole org kind of around these ideas. But one of the things that comes out of working in this strategic kind of framework is we get much bigger asks than if we were just kind of in a more service-oriented box. And they're vaguer, right? This is no longer so much about change this dashboard. Instead, more like, can you optimize our call center? Can you build a financial forecast for us? Can you discover if there's any value in this data? And these are not like poorly formed questions from like stakeholders aren't really thinking through the problems. This reflects the complexity of the spaces working in now. This is part of working at the strategic level. And so I feel our job as data people here is not just to dive in and try and build something and hope it works, but instead to work with our stakeholders to try and constrain the problem, figure out exactly what we think this solution looks like. And this is what I mean by working backwards, is we're going to start with the solution, not just kind of, take your three-pointer and hope it goes in, but instead put things in front of our stakeholders and say, does this solve the problem? Does this solve the problem? Does this solve the problem? And by doing that, you suddenly start to get very concrete discussions, very concrete requirements, that are articulated and you can run with and be much more successful. This process is really cheap. This is where you want to spend your time. You kind of want to build it as few times as you can and get as close to right as you can. And to get to kind of the point of this, I think you do this by just faking your data. And I don't mean, Monte Carlo bootstrapping. That's cool if you can do it. But I think with what has been, at least to me, surprisingly little vague fake data, you can actually kind of turbocharge these conversations and figure out exactly how you're going to deliver value here. So let's dive into a couple examples. So one thing we were asked to do this last year was to build an ARR model. ARR stands for annual recurring revenue. The thing that's tricky about this is it sounds simple, but this is not an accounting metric. This is not double entry bookkeeping. This is a financial forecast. And so the way that every company interprets what it means for something to be revenue, to be annual, to be recurring is and should be different. It depends on how your company considers when is this contract cleared. Is this a one-off service? Is this recurring? Is this a service that we think we can offer every year? It's basically all corner cases. And it's really hard for folks to explain this to kind of do the full brain dump for you into requirements. So we had a cross-functional team across the company that was working on this with us, and we were just kind of starting to feel the wheels spinning. So what we did is we just made an entirely fake one. We put a spreadsheet together, we put a forecast together, and we said, if we made a forecast that looks like this isn't even our company's data, but if it looked like this, would you be able to use this? And all of a sudden, the conversations became very concrete. People had very concrete opinions about churn versus contraction, upsells versus expansion, single year versus multi-year contracts, all the corner cases about this broker and this way, this specific product is configured differently in Salesforce. All of it just kind of fell into our laps. After a few rounds of that, then we actually went to DBT. Then we actually built our model, and we just got it right the first time. Our analyst was able to spend time building and not just building and exploring. And to get to Michelle's kind of testimonials, like the testimonial was like, I've never worked this way before. This is great. Like I had everything I needed, even though we started the project just as vague as some other asks. Next one is a little bit of a bigger idea. We had this really exciting project. We were going to build a feature. It was a data-driven feature. It's around healthcare costs, and I'm going to editorialize this a little bit. Let's just say it was about vision savings. And so the data was kind of this new data we're getting access to, and we knew we wanted to do something with it. But the catch-22 is, this is all HIPAA data. We're not going to have this data until people start using the feature. But the feature still rests on the data team being able to find value in the savings. So, we're sitting around, this is like 18 months out, and people are like, this is great. And then data, you'll find the savings, right? And we were like, can we maybe co-sign this? Can we slow this down? And so what we decided to do is, instead of faking the data, we just faked the entire feature. I was just like, look, I'm just going to assume that we have everything we need. This is 100% effective. And then we pulled some parallel data, vision data from somewhere else that wasn't quite what we needed. But again, doesn't matter. We're abstracting all that away. And I said, hey, if you were to run this feature, and let's say you're going to save money on, going to your ophthalmologist, getting your prescription, you're only going to save this much money. Is that enough money? If we could save 100%, they're like, no, that's too much. We need to look at glasses and contacts too. They're like, okay, well, there's only this many glasses and contacts kind of per 1,000 people per year. Is that going to work? They're like, no, because then the small companies won't see enough savings every year. So we need to include something else. All of a sudden, we didn't have a feature. We didn't have data. We were 18 months out, but we were starting to have very strategic and driven discussions with our product managers about what they wanted to build and how and why. Stuff that we thought we were going to have to wait until we had gone live, and we're just kind of YOLOing it. So again, it was really effective. I was really surprised. And we've done this in a number of other areas, but this is a lightning talk. So if you want to find me online, this is my online presence. And thanks to my friends and my team for giving me feedback on this talk.
Thanks so much, Alex. I think it's a good seed content for a book about how we should go about analytics in general. Because, yeah, I think too many teams are spinning wheels just trying to figure out exactly what their stakeholders or business needs. Well, awesome. So thanks again for all the speakers for lightning talks, and I'd like to transition to our final part, which is panel discussion. So today with us, we also have Julia Scottenstein, Carla Goudreau, and Chad Sanderson, who are joining us from Fish Channel Analytics, Devoted Health, and Convoy, respectively. So I'll just give it a chance for them to introduce themselves before we dive into questions. Julie, you want to go first?
Sure. Thanks, Gleb. It's so great to see DBT mentioned in so many of the lightning talks. I really enjoyed it. But for those of you who don't know me, I'm a product manager at Fishtown Analytics. We're the makers of DBT, which is a popular open source project that lets you transform your data. And it also helps you bring a lot of software development best practices into your data workflow. So you can version control your models, you can document them, test it. And part of the Fishtown that I work on is DBT Cloud, which is our hosted offering that lets you schedule DBT runs, brings a lot of CI/CD out of the box for your workflows. We also have a really great IDE in the cloud as well that kind of simplifies the development process for analytics engineers. And before joining Fishtown, I was an investor at a venture capital firm, and I invested in Datafold. So it's fun for me to also be on the operating side and be with all of you.
Awesome. Thanks, Julia. Carla?
Hi, everyone. I'm Carla Gaudreau. I am the head of the data engineering team at Devoted Health. And in addition to data engineering, we're kind of expanding that group a bit. I now oversee a part of the data science team that builds data products, because we're doing that more and more these days, as well as we're starting to build out an analytics engineering team as well, with the use of tools like DBT and soon to be Looker. So super exciting stuff going on in the data world at Devoted Health. And just really quickly, just to give you a quick background of Devoted Health, we are we consider ourselves a payvider. So we pay for healthcare for our seniors by offering a Medicare Advantage insurance plan for seniors in certain states and counties. But in addition to that, we are also a provider because we provide a medical group. So we have doctors and nurses on hand so that we can kind of evaluate our data of our members and take better care of them as a result. So it's a super exciting place. One other thing to note is that we also build all our own technology, which makes the data space in this area even more challenging and exciting. So.
Awesome. Yeah, I'm sure if you combine the two worlds of providers and healthcare plans, there's a lot of very interesting and challenging data to work through. And we're actually going to chat about that in a moment. So Chad?
Hey folks, I'm Chad Sanderson. I'm the product lead for the data platform team at Convoy. We're a data engineering and engineering team focused on solving internal data product problems. And we also own a lot of third-party tools and open source technology as well. Convoy is a digital freight brokerage. So we're a Series D company with around a $3 billion valuation based out in Seattle. We have lots of very small data challenges. So small sample sizes, not too many shippers on either side of our B2B marketplace, but lots of machine learning that goes on and sort of powers the part of our business. So different type of challenge, but still very interesting.
Awesome. So I'd like to start our discussion with talking about data quality at scale. And scale can mean different things, right? The size of organization, the size of data, the just sheer complexity of the data sets. And we have with us today folks from different companies and industries. And so these challenges come in different varieties. And we have three really large companies represented today in terms of the size of their data team. So Shopify, Lyft, and Convoy. So you guys have what, 50, 100, maybe 200, over 200 data users and data developers. So I'm really curious about your point of view on one, my controversial point about investing first in the reliable change management, but actually also more broadly, where have you found the highest ROI in terms of improving the trust and minimizing data downtime in your organizations? So maybe let's start with Chad, since we haven't heard from you yet.
Sure. So I think at a high level and a medium level and a low level, I agree with your point. I think change management is extremely important. in our experience, there's sort of two components to good change management. There's sort of the engineering problem. So when something changes in production, like a service changes, maybe a field gets altered, and that breaks something downstream, and that's pretty critical to understand. And then there's a change to the data warehouse. So data scientist is going to go out and make a change to a table or a column, write a PR or something like that. And both of those have some pretty severe change management issues. Up until recently, we haven't had a great process around either of them. And I think there's sort of a third problem that's sort of maybe floating above the other two, which is that when a data scientist is making a change in the data warehouse, they really are not thinking in terms of tables most of the time. They're thinking in terms of business abstractions. And so when they're making these changes, oftentimes they have a thought in their head of what a column should be or what a table should represent. And maybe that doesn't match what it actually represents, and they don't understand how other people are using it in maybe a way that's different than they thought. So there needs to be some sort of conversation and communication at this like business logic abstraction layer. And it's very challenging for those conversations to actually happen in a structured way. For us, they happen through Slack, right? So people will say like, hey, I'm going to make a change to this table, or I need to understand this table. But that's sort of there is sort of a layer, or like a ceiling or a gap between what one data scientist thinks a change actually means and what it actually means. So that's a problem we're trying to solve as well.
Jason, Michelle, curious on your thoughts as well.
Yeah, I 100% agree with what Chad was just saying right there. I think a common scenario we hit is this disconnect between producers and consumers. A producer might be some product team producing some events, and they inadvertently introduce a change. Maybe it was to benefit them without any understanding of the downstream impact of that, right? So things like lineage, being able to communicate when consumers feel that pain, being able to communicate back the issues quickly to get remediation, following the steps quickly. I think, at the scale of Lyft, one thing that really we've been working on is you hit on like enforcing a process and changing the culture. We started to realize that, yes, our data, we have data products. We have, and some are more important than others. Not all data means the same to the business. And so the first thing for us was, let's figure out what our core data assets are. Let's invest heavily in those and put those strong guarantees and build a culture around that, and then start to replicate and expand that out. And so that's taken into account all the things you kind of mentioned in your talk. I mean, a big thing for us was we have important data assets that don't have owners, right? So figuring out ownership and stuff like that. So when you get a large enough scale, you have to understand that not all data is equal. Be able to understand how it aligns to the business and invest in that with the right guarantees and strong guarantees.
Yeah. 100%. Not all data sets are equal. As part of our launch with DBT, we wrote like a blog post on Shopify, and it talks a lot more about what we've landed on for this. But one way that we're trying to find this balance between like really quick iteration speed, prototyping data models, and also these like super reliable production finance data sets that shouldn't go down, is trying to bring back this like backroom front room notation, where sort of everything starts by default in the backroom, and we have a lot of restrictions around how they're used, because we make the assumption that they're these sort of data sets with sharp edges, and the owners really understand them and not necessarily the consumers. So we sort of limit like the producer and the consumer of these are the same. And we say that you can't build on top of backroom data sets unless you are that owning team. And this can lead to duplication, but it's kind of okay. Like that duplication is a symptom that this needs some attention on it. A lot of teams want to use it. It's very high value, and it's an indication that it's important. We should redesign this and promote it up and add more checks. And so it's kind of a way to actually tease that out. So far, it's not really something we've launched. There's a lot of like controversial discussion around this, but that's kind of our early thinking, is more of like the life cycle of the data set as opposed to classifying it right up front. Like design the front room model first, design the back room model first. It's like everything starts in back room, and let's just naturally see where it goes. Yeah. In terms of return on investment, for sure, the change management has been super useful for us on the like event instrumentation side, and having schematized events flow through and like strict evolution rules and things like that. I think that's been really, really great. We launched that like 2 years ago, and it's got crazy adoption. And just a stable thing that we can make assumptions and guarantees on. Like the schema is not going to change tomorrow without very explicit process and communication.
Interesting. And so, Michelle, on your point about the background data, so it sounds like what you guys did is you enable everyone who wants to build data with the ability to build data, right? With your dbt plus BigQuery stack, which kind of lowers the barrier.
Mm-hmm.
But you, at the same time, restrict other data users and data developers to essentially use that data, right, before it got, let's say, promoted to being sort of core or validated, right? And therefore, you minimize the risks of people being dependent, or data products being dependent on something that doesn't have an SLA, right?
Yeah, exactly.
Very interesting. And I'm curious also, Jason and Chad, how does it happen in your organizations? But also, Carla and Alex, how do you feel about enabling versus restricting and maintaining that tricky balance where you want organization to move fast, but at the same time, if it moves too fast and people just build whatever they want and source data wherever they want, maybe it can be really hard to take, responsibilities really doesn't exist, doesn't concentrate anywhere, right?
Yeah, I can say a couple points on that. I think there's two aspects where we face that. One is tooling and being able to, there is a gap, but we can't wait on a platform team to build these tools. And so you end up with this fragmented landscape of like data quality tools, and that's what we face at Lyft. And then the other part is, again, getting back, not all data is the same. So we're trying to go after this idea of, just like we tiered services, there's tiers of data products, and the process and the requirements to be a higher tier data set, or more important to the business, has additional requirements that it purposefully slows down the agility because the impact, there's too much risk there. We're still formalizing those ideas, but that's kind of the direction we're going to help mitigate this. That if you want to move quickly with new data, go ahead. But if you're going to be touching some core data asset, it's thoughtful. There's going to be some group committee governance going on around there before any actions are made.
Yeah, that's actually very similar to our approach as well, at least the way that we've been thinking about it for the last year or so. There is we sort of leveraged very heavily early on being a startup and giving everybody data access and letting them do really whatever they wanted. And we've seen a couple problematic things happen as a result of that. The first one is, so we're very heavy dbt users, and dbt is awesome. We use a few other sort of open source BI tools like Metabase and things like that. And what we saw happening is when everybody had access to do anything, the cost of building something new was actually lower than the cost of finding previously created information and leveraging that. And so you have this explosion of information, and now nobody is really sure like what the true source of truth is. And when changes get made all across the business, people are just making changes to things all the time. That's when you see a lot of these like downstream issues, like, oh, my model broke or my report broke because I'm taking a dependency on something and I have no idea what it even is really. So there was and that sort of led to another issue where like there was just so much stuff that the concept of data ownership wasn't really a thing. So data scientists at Convoy fall under our product organization. So when they are going through their sort of yearly reviews and quarterly reviews, they're mainly judged on like basis points impact to margin and other business metrics like that. And they're not really held accountable to quality in the same way that a software engineer is. And so it led to data scientists oftentimes saying, okay, yeah, I know something broke, but it's much easier for me to put together a hacky solution just so I can get through it than to invest in something scalable. And because they didn't receive any award for that, there was no reason for them to do that. They didn't get there was no benefit for them to do that. So there are some like really big cultural elements that we're trying to change around data quality. And then the other thing the way that I've sort of been thinking of it is one of the reason our code base has actually matured in a pretty nice way is because all of the tooling around change management, Gleb, as you've sort of implied, like GitHub is awesome. And that sort of principle of treating the data model like a code base doesn't really exist for the data science team. And it should just not just in terms of tables and columns, but also like the aggregations and the metrics that people end up using in reports. So having some single place where you can say, I have a metric, I have an aggregation that is valuable to the business, and now I'm ready for everybody to start taking dependencies on this and using it and reporting it sort of up the chain. I want to commit it to one place, and it should go through a review process.
Yeah, just to add to that, Chad, it seems like we have a lot of the same types of problems at Devoted Health as you do in your company, and the fact that you know, we're a fairly new startup. We're only 4-ish years old, and you know, we started giving access to all the things, which is the opposite of what I'm used to being at previous companies. So there are definitely pros and cons to that approach. The pros are you can develop super quickly and get the business up to speed very quickly. But as we all know, as data people on this call, there are lots of cons with respect to data quality. And at a healthcare company, we have the added kind of thing to think about, which is compliance. We have to be compliant because we report our metrics to the government. So add in that lovely extra added bonus, we absolutely have to add in checks and balances and tooling to ensure that, you know, something like allowing a software engineer the ability to drop a column in a table in our source system is, we have to make sure that that's not possible to do if it's a column that we rely on for compliance reasons. So yeah, just wanted to add that.
I'd be also curious to hear, so from Carl and Alex, how do you maintain high speed of development in an environment where, you know, with very strict regulations, right, for access to data? Because, you know, I think we're all, for consumer, you know, B2C consumer companies, we're all used to sort of just develop on production, and, you know, people, you know, writing SQL and having access to everything, at least in the early days, right? And so I imagine that your world is somewhat different. So how do you maintain high speed of development where you have to think about these things from the day one?
That's a great question. I can start just giving you my high level of some of the things Devoted has done to address this issue. Again, being a fairly new startup, I do think that some of the decisions we made early on have bode us well for this type of thing. As an example, you know, we have a mono repo for everything, data, all of our software eng. So we're like, everyone's fully aware of what's going on in the code base, which at first I didn't like, but now I've come to realize we need that. Another thing is we use lots of generated code. So we use like protobuf for all of our, you know, source of truth on the data side, which makes it a little more doable for this kind of work. So as an example, I just talked about, you know, for compliance reasons, we want to make sure we flag certain things in the proto as sensitive or as needed for compliance reasons. So don't ever mess with this. And because we have that single source of truth in the protobuf layer, we're able to do that kind of stuff. So I'll say good decisions in the beginning definitely helped, but on the reporting and analytics side, it's definitely messier. So I could talk about that as well as we go on, but I'll let Alex speak as well.
Yeah, I mean, I'm just hugely uptight, so this is like not really an issue for me. I'm like always whining that things aren't like, you know, documented and strict enough, but there actually do have a number of like initiatives kind of around this right now. So again, we're in a unique position. We're not part of our engineering team, so we can kind of build our own culture. And there's 5 of us. So even as the company is scaling, you know, we're scaling, but at a smaller level. So we can kind of make some changes and pivot a little bit faster on this stuff. So some of the things we've done is we really lean into DBT and some of the not just that tool, but the tools around that. So integrations with looking at using the pre-commit DBT pre-commit tool, I keep calling it the super label, but exposures, pre-commit, to kind of make sure we have all these checks and start to, as we grow, be like, okay, like this is PII and like it's cascading outward here. This is HIPAA, it's cascading outward here. Our data warehouse is Snowflake, and so we purchased that and built it for our team. So it's people have to opt in; they don't like naturally have access, and so we're putting together a formal process where, like, if you want to have that kind of raw data access, like you're a product manager, right? Like you should be able to see what's in the tables. You have to be able to see what's in the tables. Like the business owner needs to sign off on that at like the highest level. Like there's a workflow, like legal's involved. I'm tagging the VP of security like obnoxiously frequently in our Jira tickets of like, hey, can I do this? Can I do this? Can I do this? And so I don't know. I think just being able to have that autonomous full stack unit allows us to kind of own something. If someone's like, oh, like that's actually, that should not be there, right? Like two people make an MR, like they co-sign it, we broadcast in Slack, it's fixed like 45 minutes later. So kind of an argument in favor of having that kind of full stack role.
Awesome. Well, thank you for sharing. And I think the reason why it's also, the insights that both, Alex and Carla just shared are broadly applicable to everyone is because, these are examples of companies that are startups, and it means that they're moving really fast. They are on the modern data stack. They ship high quality data products despite being highly regulated. And so it's just an example for everyone else, right? So even if you're not in a highly regulated industry, that doesn't mean that you can't apply reliable and compliance-minded practices from the very beginning, right? It's still possible, especially with the modern data tools. So I'd like to shift gears a little bit and speak about tools themselves. So we have Julia and Caitlin and myself included, who are vendors in this space, in that we build tools to help everyone who's building data products lives easier. And so I'd like to start with asking a question. There was a lot of praise towards DBT. I think it's a great product, but I'm really curious, Julia, to hear your opinion on what do you think data tools, maybe DBT included, are still missing? What are the things that we still have to deliver to the data community that we haven't, in terms of the principles for reliable data product building?
Yeah, I think that's a great question. So at DBT, what we really want to accomplish is we want to be the standard for how you build and transform your models. We want things like quality and testing to be a first order principle of how you build your modern data stack. And our product's open source. You can get most of the benefit of DBT without paying us anything. And we love that because we think that this is just moving the whole industry forward. One of the really interesting things that I keep seeing is both this tension that we already brought up between reliability, durability, trustability of your data, and ease of consuming those models or understanding those models by business owners. That's a challenge that's really, really hard that I don't think we've solved yet. But the other interesting one I wanted to talk about is just how the stacks become more unbundled. You're getting tools that tackle different parts or different problems. Carla, you mentioned PII data specifically, like there are whole companies that focus on that. And I think that's a great thing because the opportunity is so large for companies to focus on, specialize in different areas. The challenge then becomes interoperability and having this open ecosystem where you can use all of these products and still solve your problem at the end of the day, which is I need reliable data. I need to give good answers and help with decision making in my company. And so that really, in my mind, is a huge challenge that we as vendors, as you called us, but just participants in the ecosystem have to think about is the end user. How do these all kind of stitch together and deliver really good, at the end of the day, better data stack versus more confusing?
Yeah, I couldn't agree more. I think that the interoperability between data tools is an emerging trend, and I think there are a few players, like for example DBT, that are or some metadata platforms as well that are really well positioned to be sort of the hubs of the data and exchange. And we don't see right now many protocols for how this exchange happens, or what is the format of data, or what is, the way that we all communicate. But that's definitely something that we also sense from our standpoint when we are working with customers. So also trying to bake it in the product. Yeah, just to give an example, so Amundsen recently, which is a really great metadata platform built by Lyft, announced that they have an ability to natively support data lineage, which we spoke about earlier, right? Why is it important? And it's also important to be part of your sort of data discovery and bridging the gap between producers and consumers. But but Amundsen itself doesn't support lineage as a metadata piece. So you have to pretty much bring it on yourself. And it's a really hard problem because it requires static code analysis. So one thing that we did, for example, is build an API that allows to take lineage from Datafold and bring it into Amundsen. For example, if you want to use that as your metadata platform. I know that dbt also offers an API for pulling out metadata that already exists in your sort of dbt models and manifests, so you can also distribute that to other tools. So Caitlin, also curious to hear where do you think is your vision for where your product should go, and broadly the sort of notebook / product building experience?
Yeah, well, I think that's a very broad question in terms of where we're gonna go. I do think, to sort of like jump on to what Julia was saying, I think that's a really interesting area that we're thinking about a lot right now, which is what are the interfaces between our product and the rest of the data stack, and how do you do that in a way that doesn't mean that we have to go through and build, there's so many different products, and we want people to be able to use the products that fit their workflow the best and not have that sort of make decisions for them elsewhere in the stack. But how do you do that without sort of solving this n-squared problem where you have to build integrations between all of the different, every single different data tool? And so we've been thinking a lot about that, about how do we put Hex into a format where we can kind of just unlock all of these different sort of creative solutions that users might have. And maybe we build a few first class integrations, but maybe we also just have right now where we're thinking about okay, well, if you could manipulate all of this stuff, through your GitHub repos and things like that, all of a sudden then you have this integration point that it works with your CI, it works with your, models, it works with all of those things. And so really thinking through some of those sort of key, you were saying, sort of you end up with these nexi of places where you can integrate with, and then that unlocks a huge amount of user creativity. I think some of the other stuff that we're really, really excited about is kind of going beyond notebooks. It's okay, so we have a notebook model and people love notebooks. And so that's kind of why we started there. It's a very powerful, very familiar paradigm, allows people to get started really easily. But what are some of these more powerful computation techniques? I think a good example is introducing reactivity and things like that on top of a notebook paradigm that allow people to do in some ways more flexible and more powerful data analysis, but also kind of build these more performant and more responsive data apps. And so we're doing a bunch of explorations there, and okay, can we actually take the notebook computation paradigm and push that forward and build on top of that to unlock sort of new abilities and new superpowers for users who are building with those.
Wow, reactive notebooks. That sounds really cool. Yeah, so super excited about the conversation today. I wish we could go for more, but I also wanted to give everyone a chance to grab a brief before their next round of meetings. And thank you very much, all the speakers and panelists today. Thank you for contributing your time into preparing, thinking, sharing your ideas. Everyone here does really awesome work in their domains. And to everyone who is listening in today live and will be watching recording, stay tuned for new meetups. We'll have another one probably in July later this year. And we'll be also sending out a digest of the meetup with all the talks as well as the panel recorded and summarized in bullet points. So happy data building, and see you soon.